Problem 3.2. The focus question in today's problem is, when comparing two rational numbers such as fractions, mixed numbers, improper fractions, or decimals. So when comparing rational numbers, what are some useful strategies for deciding which is greater? So these are strategies to help us decide whether a number is greater than another number. So 3.2 is estimating and ordering rational numbers, comparing fractions to benchmarks. It says when you solve problems involving fractions and decimals, you may find it useful to estimate the size of numbers. One way is to compare each positive fraction to 0, 1/2, and 1. These numbers serve as benchmarks. So a good technique for determining and comparing or ordering rational numbers is to compare each rational number to 0, 1/2, and 1. These are called benchmarks. Okay? 0, 1/2, and 1. You can also compare each negative fraction to the opposites of the benchmark. So on the other side over here, so first of all we have 0, 1/2, and 1. On the opposite side we have -1/2, 1, and -1.5. So you can compare to the opposite of the benchmarks as well, 0, 1/2, and 1. These benchmarks divide the number line below into 6 equal intervals. The intervals between -1.5 and 1, and the interval between -1 and -1/2, and so on. So these are intervals, right? So we'll use these benchmarks, 0, 1/2, and 1, 0, -1/2, -1. We'll use those to help us compare and order rational numbers. So here is the blown up version of the different intervals, and we can use these benchmarks. I'm going to highlight these benchmarks. These are the that's not what I wanted. We're going to highlight these benchmarks to let us know that these are the numbers that will help us compare and order rational numbers. And we just have to figure out what interval certain numbers would fall into. Would they fall in between 0 and 1/2, or 1/2 and 1, or 1 and 1 1/2? Or would they fall in between 0 and -1/2, -1/2 and 1, -1, and -1/2, -1 to -1 and 1/2? Let's do one example. So in your book problem today, they'll give you a whole bunch of little cards that have numbers on them. So let's just take one example. Let's say I have 8/10, and we want to figure out which interval it falls in between. Okay? So right off the bat, we see that this number is positive. So we know it's going to be in one of these three. Here, here, or here. All right, so 8/10. One strategy I would suggest is, when at all possible, reduce. All right, so I would look at 8 and 10. I'd say, okay, I know they're both even numbers. I can divide the numerator and the denominator by 2. 8 divided by 2 is 4. 10 divided by 2 is 4/5. All right, so 4/5. Well, I also know that 5/5 would be 1, right? 5/5 would take me to 1. But we have 4/5, so we are almost 1 but not quite. So if I had to take a red dot and put it somewhere in between these benchmarks, I'd probably put it right in here. So I'd say 4/5 falls between 1/2 and 1. It's not quite 1 because I know 5/5 is 1. So there's one strategy. You can also take and turn your fractions into decimals. because you know what these are as decimals, if you needed to. There's other ways. I'll be interested to see how you come up with where all of these different fractions from the problems live. Good luck, and don't forget the benchmarks. Once again, for the last time, the benchmarks are 0, and, oops, I'm hitting the wrong button, 0 and 1/2, 1/2 and 1, or -1/2, -1. 0, 1/2, and 1. And then the opposites are the negatives of those. Those are your main benchmarks that will help you compare and order rational numbers.